Okay, today we're going to be looking at a little bit more to do with normal distribution. We're going to be looking at z-scores and z-tables. A z-score is something you can calculate. You can very easily calculate the z-score. A z-score tells you exactly how many standard deviations from the mean a certain data point is. Alright, so a z-score describes the position of a raw score in terms of its distance from the mean when measured in standard deviation units. Z-score is positive if the value lies above the mean, negative if it's below the mean. We can calculate this by taking the score, subtracting the mean, and dividing by the standard deviation. This will tell us exactly how many standard deviations that particular score is from the mean. Once we have that score, we can reference something called a z-table. A z-table will tell us exactly how much of the data is below that particular z-score. Okay, so for instance, if we look at a standard deviation here, and let's say that this z-score right here is like negative 1.5. Okay, so right here, that's negative 1.5 standard deviations below the mean. Okay, so the mean is right here. This is negative 1.5. This is 1.5 standard deviations below the mean. Then this shaded area, we would have to look for negative 1.5. So negative 1. 0.5 is right here. And that tells us that this shaded region right here is 0.0668. Okay, so that would be how much data is in that shaded region. Okay, that's about 6.68% of the data in that shaded region. What if it was like positive 1.5? It was on the other side. Well, then this shaded area would have 0.9332, or 93.32% of the data would be in that shaded area. Okay, so we can use this to very quickly calculate certain values or certain probabilities based on a particular z-score. So for instance, the distribution of weights of all boxes of Raisin Bran cereal is approximately the mean of 20 ounces and a standard deviation of 2 ounces. We want to know the probability that the weight is less than 19.2 ounces. And we can quickly calculate this using a z-score. Okay? So here's the mean. Here's 1 above, 2 above, 3 above, 1 below, 2 below, 3 below. Here's the mean, which is 20. So let me calculate the z-score first of all. So I would do, it's x minus mu over sigma. Okay, so in this case, x is 19.2 minus 20 and over 2. Which is negative 0.4. So what I'm looking at, the z-score for this particular value tells me that the value is negative 0.4 standard deviations. So that would be 0.4 standard deviations below the mean. So this is where the value lies. Okay, it's sitting right here.
I'm finished, Mr. Morning.
That's where 19.2 is. And we want to know how much of the data is below that. Well, luckily, the table will tell us exactly how much of the data is below that. All of this, all I have to do is look for negative 0.4 on my z-table. Okay, so let me get out my z-table and let me look for negative 0.4. Okay, so right here, negative 0.4 0.3446. At 0.3446. Okay, so that's the probability that something is below, or the weight is below 19.2. And this is the benefit of having a particular z-score, because it helps you very quickly calculate using the table how much data is below that particular point. 5b, we want to know the probability that the weight is greater than 19.2. Okay, well luckily we already have the z-score for this. We calculated it. Okay, actually I should probably just get my stuff back. Let me see. Yeah. So I want the probability that the weight is greater than 19.2. Well, that's actually easy to do with this z-score, okay, because all I need is the opposite side over here. But remember, all of the probability here is equal to 1. Okay, so if I have this z-score for below, then I just need to subtract that from 1 to get the z-score for above. So 1 minus 3, 4, 4, 6. Okay, so 1 minus 0.3446 gives me 0.6554. Okay, so the probability of it being above 19.2, so in this orange, 0.6554. Okay, so let's take a look at the next one here. So number 6, we want the probability that the weight is greater than 18.1. I'm just going to draw a quick sketch so that I know what I'm looking at. Alright, so let's change this to a z-score. So we got x minus mu over sigma. So that's 18.1 minus 20 over 2. So 18.1 minus 20. Okay, divide that by 2. So we get negative 0.95. So my z-score is negative 0.95. That tells me how many standard deviations. It is almost 1 standard deviation below the mean. It's negative 0.95 standard deviations below the mean. Okay? So, and I want to know the probability that it is greater than that. Okay, so I want to know over here. Well, my z-table is going to give me this right here. So I need to calculate this first from my z-table. So negative 0.95. Okay, so negative 0.9 is right here. And then I need negative 0.95, okay, which is right here. It's 0.1711. Okay, because I have to match up the negative 0.9 and then the 10th digit, which is the 5, so 0.1711. Okay, but remember, what I actually want is this stuff over here, okay, greater than 18.1. Okay, so I'm going to have to subtract that from 1 to get that. So 1 minus 0.1711. Okay, so I got 0.8289. Great. So the probability of being greater than 18.1 is 0.8289. And let me look at number 7. So I want the probability that the weight is less than 24.5. Just make my sketch so I know what I'm looking at. Doesn't have to be very nice, okay? I just need to know what I'm looking at here. Okay, so my z-score, x minus mu over sigma, 24.5 minus 20 divided by 2, 2.25. So this value is 2.25 standard deviations above the mean. Okay, so when I go to calculate this from the z-table, it's going to give me this, which is exactly what I want. That would be all the values less than 2.25, or 20, yeah. So let me take a look at my z-table. I'm looking for 2.25. Okay, so I'm on this one because these are positive. So 2.2, and then the 10th digit is right here, the 5, so it's 0.9878. So the probability of a particular box having less than 24.5 ounces in it is 0.9878. Okay, like a 98.78% chance that a box has less than 24.5 ounces in it. Pretty good chance, okay, a very high probability of that happening. And we got number 8, probability that the weight is less than 16.7. Okay, let me make a quick sketch so I know what I'm looking at. Calculate the z-score. So 16.7 minus 20 over 2. Negative 1.65. Okay, so this particular value is negative 1.65 standard deviations below the mean. Okay, now when I go to my z-table, it's going to give me what's below this, and that's exactly what I want. Okay, I want to know the probability that it's less than that value. Alright, so I just need to go to my z-table, and I'm looking for negative 1.65. So negative 1.6 is right here, and then I need the 10th digit, which is 0.05. So that's 0.0495. So 0.0495. So probability. So that's like a almost 5% probability that or a 5% chance that a given box has less than 16.7 ounces in it. Okay, so not very high. Not very high at all. Whoops, it looks like I might need that because number 9 is asking for the weight greater than 16.7. Okay, so I probably am going to need what I just had, because if that's the probability of it being less than 16.7, then the probability of it being greater than 16.7 is just going to be over here, which is 1 minus the probability that I just calculated. So 1 minus 0.0495, which is 0.9505. So this is the probability that a given box will have more than 16.7 ounces in it. And that's like over a 95% chance. Pretty good probability there.